Hi there everyone. So today we are going to be factoring polynomials. Now, none of this information again should be new. The first unit for us is actually going to be probably the easiest unit that we will be looking at all year. So I don't want you getting any kind of misrepresentations of the course. The first unit is totally a review unit, and then we will start getting into some new and different topics and concepts. So to start, we're just going to start with factoring polynomials, do a little bit of dots, and we're going to call it a day. So what is GCF? You guys should all know by this point that GCF is the greatest common factor. Okay, it's the greatest common factor. It's the largest divisor of two or more terms. Okay, we also have the following examples. So let's take a look. What's the GCF of 10 and 15? Well, I just wrote out all the factors of 10 and 15, so this should be super, basic knowledge for you guys. And you're just going to see what's the largest value that they have in common, and that would be 5. So the largest number between them is 5, so that would be the GCF. You could do that again for 18 and 36, write out all of the factors. So we have 1, 2, 3, 6, 9, 18. Again, I'm going through this kind of quickly because this is all things that you should know already. And 18, 36. Okay, so you can write them all out unless you already know it off the top of your head, but you can see here that the number they share in common is 18. So the GCF here is actually 18. Okay, why don't you guys try 3? All right, and I will just post the answer here. Again, really not a whole lot of work to be shown, but I will just post it just so that you have it. All right, but hopefully we know how to find that. All right, so we're going to factor using the GCF method. So again, this is just a reminder for those of you that were like, oh my gosh, I haven't done factoring in forever. You're going to get the practice now. So factoring using the GCF method, we are going to take out the greatest common factor, divide the expression by the GCF, and then the quotient is going to be the second factor. Okay, so you always want to ask yourself, what is the largest number that I can divide out by? What variables can divide out and how many? So let's take a look at the first problem. We'll do that together. All right, I have 16 and 32, so I'm just going to look at the coefficients first. Between 16 and 32, well, 32 is divisible by 16, so my GCF between those two numbers is 16, so let's take out a 16. Now if I look at my x squared and x cubed, the most number of x's that they share, so let me write this out. This is really x times x, and this is really x times x times x. They share 2 x's, which is x squared. So my GCF is going to be 16x squared. Okay, so I'm going to divide everything out by 16x squared, divide out by 16x squared. So here I'll be left with 1, because 16x squared divided by 16x squared is 1. 32 divided by 16 is 2, and then x cubed divided by x squared is x. So that's factoring out using the GCF. You guys can try 6, and I'm going to do question 9 with you. Okay, so again, look for the GCF amongst all 3 variables and coefficients. So of the coefficients, I see 9 is the largest number between them that they all share. And out of all the A's, the most that they share is 1A. So my GCF is 9A. We're going to divide out, so I have 2A to the 4th. Divide out my second set of terms, which is 3a squared. And then lastly, 9a divided by 9a is 1, and there's subtraction between them. Okay, so that's what number 9 should look like. You all can try question 8. And I guess I will just write what the final answer is to make sure that you understand how to get there. Again, the final answer here is x times 6x squared minus 5x plus 2, and then up here our final answer should be the following. All right, make sure you get those solutions, guys. Make sure you get those answers. Okay, let's move on to the next page, which is page 21. So moving on to page 21, I want to take a look at question 10. So this is a little bit more challenging of a problem here. So we'll do this one together. We have, let's see, the area of a rectangle is represented by the polynomial. So we have area of a rectangle is given by this polynomial. We know the width is given by this binomial. We want to write a monomial expression, so we should just get one term in the very end, in terms of x for the length of the rectangle. So it's really saying find the length in terms of x. Well, you guys should remember area for a rectangle is length times width. So area is equal to length times width. They told us the area is 16x squared plus 56x. And they told us the width. The width is 2x plus 7. Well, I'm going to substitute these pieces in. This is my width, so that's going to go in for W. And this is my area, which is going to go in for A. And then we'll solve for L in the very end, which is what we want. So let's rewrite this. We have 16x squared plus 56x is equal to length times 2x plus 7. I want to get L by itself, so I'm going to divide both sides by 2x plus 7. And now we're going to have to solve for L. Well, we can do long division, but the whole point of this lesson is factoring. So what do you think we should do? We're going to have to factor. So let's factor this numerator. When I factor out the numerator, I'm going to take out an 8x. I'll have 2x plus 7, right? Because they both share an 8, and this shares an 8. And the most x's they share is just 1x, right? Okay, and nothing can factor in the denominator. That just stays as that 2x plus 7. So I can cancel. And that's what I'm left with. My width, I'm sorry, not the width. The length, we were solving for L. The length is 8x. All right, great. Now the next piece says if the length is 80 centimeters, what does the width of the rectangle represent? Well, we have a formula here for length. Length is equal to 8x, and the length is also equal to 80. Well, let's just set these things equal to each other. 8x is equal to 80, so I know x is equal to 10. So that helped me find x, but I still want to know what the width is. Well, here's my equation for width. Width is equal to 2x plus 7. So let's plug in x. We have 2 times 10 plus 7, and I get the width is 27 centimeters. All right, awesome. You guys can see questions like this where we have word problems where I'm asking you to solve for different things, okay? All right, moving right along. Let's take a look at dots now. So that is on page 22. So difference of two perfect squares. You guys should remember dots when you were in Algebra 2 especially. You guys definitely did a lot of factoring. So for our warm-up question, I just want us to just double distribute this. So let's do this together, or you can pause the video and try to do this on your own first. Okay, and guys, at any moment, you can always pause the video before I go through the problems if you want to try them yourselves. So I'm going to double distribute. We have x squared plus 3x minus 3x, and then minus 9. Notice the middle terms cancel out, and I'm left with x squared minus 9. That's why this is a difference of two perfect squares, guys. I have the x minus 3 and x plus 3, right? The difference of two perfect squares from my x squared minus 9 results in these two factors, where we take plus and minus 3. So factoring, if we forgot, that's why I'm reviewing this now. So factoring the difference of two squares would look like this form, a squared minus b squared. Okay, again, that's called the difference of two perfect squares, where the factors would be a plus b and a minus b. All right, we can look at the example that we just did before from this warm-up, right? We can rewrite this as, well, x squared is x times x, and 9 is the same thing as 3 times 3, or negative 3 times negative 3. Okay? So this method is only going to work when there's subtraction in the middle. So you need to have subtraction in the middle. Each exponent is even, and the number values are perfect squares. Have to be perfect squares. So by this point, you guys should know your perfect squares. All right. I mean, for the most part, you guys are juniors and seniors. You've all taken algebra, algebra 2. Like, you should know your perfect squares. Okay. And if you don't, I'm going to review them right now. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. I think you see where this is going. I'm going to fill in the rest of these so you can pause the video here and do that as well. All right. So again, nothing really new here. So let's flip over to the next page. So now we should be on page 23. So again, these are the questions that you guys have to ask yourselves. Is it dots? Are there two terms? So are there two terms? Is there subtraction between the terms? Is the exponent even? So we're looking for even exponents. And then lastly, you guys should all remember this, we're looking for perfect squares as well. So are they perfect squares? And we just went over what some of the perfect squares were. Okay, so let's take a look at some examples. So some of these, there's a chance that it might not factor into dots. So I'm going to do x squared plus 9 and x squared minus 25, and you guys can do x squared minus 8. So let's see. For x squared minus 25, well, yep, there are two terms. That checks off. Even exponent, perfect squares, and there's subtraction between them. So this is dots. It checks off all four things. So we have x plus 5 and then x minus 5. All right. Now we have over here x squared plus 9. And immediately I'm thinking x plus 3, x minus 3. But I got to check off all four rules to see if that's actually right. Two terms. Yep. Even exponents. Perfect squares. Oops. There's no subtraction in the middle. So this is actually wrong. This is not factorable. Not factorable. Okay, let's take a look at just a little bit more practice with our perfect squares here. So let's maybe up the difficulty a little. If I were to take a look at this example, I have 9x squared minus 16. All right, well, can I do dots right away? I always want to look for a GCF first, and I don't see one. There's nothing in common between 9 and 16. So yeah, I guess I can do dots right away. Got my perfect squares. All right, so the perfect squares. I have subtraction in the middle, two terms, and I have an even exponent. So yeah, let's do dots. We have 3x minus 4 and 3x plus 4. Okay, so let's keep going. Let's take a look at this problem up here. You guys are going to do the other ones that are colored in red. All right, so again, we should always look for a GCF first before we do dots or, any kind of factoring method. So we'll always look for a GCF first. And I actually see one. These are both divisible by 9. So I'm going to take out the 9. And after I take out the 9, I'll be left with x squared minus 4. Now we can factor x squared minus 4. That's dots. I'll get x minus 2 and x plus 2. Ooh, that one was a little tricky. You got to notice the GCF first and then do dots. Okay, it would have actually been wrong if you factored it like this. 3x minus 6, 3x plus 6, because that's not factored completely. Okay, this is not factored completely. Okay, let's move on. So we have page 24, and we are done for the day. So let's take a look at some practice problems on page 24, and then we'll be done for the day. All right, so for question 5, let's do that one together. I always look for that GCF first, but there is none in common between these terms. So let's see, is it dots? We've got even exponents, subtraction in the middle, perfect squares, and it's two terms. So yep, this is dots. So let's take out those perfect squares. Square root of 25, we've got 5m minus n, and then 5m plus n. Done. That's it. Similarly for 17, again, perfect squares, even exponents, subtraction in the middle, and I have two terms. So everything checks off. Okay, so now let's complete dots. So I know the square root of 144 is 12. I have x minus the square root of 25 is 5. Careful here. This is y to the 4th, so that's going to be squared. Then I'll have 12x plus 5y squared. All right. And lastly, I will do question 9 with you guys, and you guys are going to do 6 and 8. So I've got two perfect squares, good. I've got even exponent. I have two terms, but there's addition in the middle, so this is not dots. It's not factorable. Okay, great. Let's just take a look at the bottom of this page, and then we are done, guys. We are all done for the day. Okay, so for question 10, again, we always want to look for the GCF first, and I actually do see one. They have 4 in common, so let's take out the 4. We have x squared then minus 9y squared, and we can do dots now, right? We can factor this is an x squared, that's a perfect square, 9 is a perfect square, y squared is a perfect square. We've got that subtraction in the middle, there are two terms, even exponents, so yeah, this is dots. Awesome. Okay, you guys are going to do 11 and 13. And lastly, our last problem for the day will be 14 together. Again, I wanted to see if there's anything in common, and I don't see anything in common. I've got 1/4 here in 81, so that doesn't help. Let's see, I've got two terms, so that checks off. Subtraction in the middle, even exponents, and yeah, guys, that's a perfect square, and so is that. Because if you think about it, square root of 1/4, well, square root of 1 is just 1. What's the square root of 4? 2. So this can really be written as, we have 1/2 x to the third minus 9, and then 1/2 x to the third plus 9. And that's it. We're done. Alrighty, guys, I will talk to you soon.